We're going to be in section 3.3, polynomial zeros. And factors. What we're going to be building out of this. Okay, so with polynomial zeros, if k is a zero of the polynomial, k is the same thing we talked about last week, then x minus k is a factor. Right. Now, out of that, what we're going to do is we're going to be building up into factoring a polynomial completely and finding all of the zeros of a polynomial. And start off, they're going to give us some of the information that we need. So let's just start with some examples here. F of x, 3x to the 5th minus 2x to the 4th plus x cubed minus 8x squared plus 5x plus 1. And they want us to check is the given a factor. Okay, so this is the given. That x minus 1 is the given. Is that a factor? Okay, well, the test for that is to take that and run synthetic division with what value? What should be on the shelf there? Positive 1. So what we really do is we set x minus 1 equal to 0 and solve it and get positive 1. So 1 goes on the shelf, and then we have our coefficients here with that. So this is exactly what we did in lab just a few minutes ago. None of that has changed. And then that's going to be 1 and 1, 2, 2, -6, -6, -1, -1. And yes, it is a 0. Okay, so that tells us that x minus 1 is a factor. What it also allows us to do is rewrite this polynomial as a factored polynomial partially. We're not factoring completely yet, but the factoring that happens is the x minus 1 is a factor. So we get that guy out in the front, and then all of this stuff is also a factor of that polynomial that we have. We started with x to the 5th power. Anytime we do synthetic division, it brings it down 1 power. So that's a 3x to the 4th plus 1x to the 3rd plus 2x squared minus 6x minus 1. So we started the process of factoring that polynomial by using synthetic division. Because that's the remainder. Yeah. No, if it's plus 0, then it doesn't change anything. If there were a remainder, then it wouldn't be a factor of the polynomial. What they were asking you to do is do the division problem, and it didn't matter if that was a 0 there. With what we're doing in this section and what we're trying to build here, it has to be a 0 for it to work there. Yes, ma'am. Yes, ma'am. Yes. I knew that's what you was going to ask. Yeah, yeah, it is. Okay, so that's the beginnings of what we're doing here. Is we're deciding if something is a factor, and then using it to start factoring that polynomial. What we're going to be able to do here by the end is take a polynomial given nothing and factor it completely, and that's going to give us all our zeros out of that. So this is just the beginning of that thing. Let's look at example B here. Let's say we had f of x, 6x cubed, plus 19x squared, plus 2x minus 3. And they tell us that x plus 3 is a factor. and they say factor f of x completely. Okay. That's our instructions. And they give us a factor. So if they give us a factor, what's that tell us about the remainder when we do the synthetic division? It's got to be 0. That what that is, they're just being nice to us and giving us part of the problem, saying, okay, here's a factor. You know that when you run that with synthetic division, if you don't get 0 as the remainder, you did something wrong. That's what basically that does for us. So let's set up the synthetic division, and what goes on the shelf for this one? -3. So we said x plus 3 equal to 0. Subtract 3, and that's why -3 goes on the shelf. Okay, and then we put our coefficients there: 6, 19, 2, -3. And if I run synthetic division with that -3, I better get a 0 right here. I should know that happens. Drop the 6 down. Hey, what do you know? It did work. I got a 0 there. I did it right. Okay. Now, what does that allow us to do? That allows us to take this piece and rewrite it as 6x squared plus x minus 1. And they told us to factor this thing completely. So right now, we know that's the factored form of f of x up to that point. Can we factor the 6x squared plus x minus 1? Or we can try to, at least, using that x method of factoring that we did weeks ago. Multiply to be -6, adds to be +1. It'd be 3 and -2. And then we group. Those have 3x in common. These have -1 in common. So now the factors are 3x minus 1, 2x plus 1, and then this x plus 3 that they told me was a factor to begin with. There is the factored form of that polynomial. So we use synthetic division to break it down into a quadratic, and then we factored quadratics before, actually quite a bit. So we then used our methods, our x method for factoring that quadratic to break it down further. Okay, so that's in the factoring completely idea. Let's look at another one. Here's our function. F of x is x cubed plus 4x squared minus 5, and x minus 1 is a factor. So if we know that's a factor, we know that when I run that through with synthetic division, I should get a 0 as the remainder. So I've got a 1, 4, 0, -5. Why did I put that 0 in there? Yeah, take the place of the plain x that wasn't in the problem. I've got to have represented. What goes on the shelf? +1. Then you drop this 1 down and multiply. Yeah, get a 0 at the remainder. Okay. So right now it factors as x minus 1 and x squared plus 5x plus 5. Right now that's all it factors as. Let's try to factor that quadratic, the x squared plus 5x plus 5. I need something that multiplies to be 5 and adds to be 5. The only things that multiply to be 5 are 5 and 1. 5 plus 1 is 6, not 5. Well, what about -5 and -1? That's -6. That doesn't factor any further. That is the factor form. You're going to try to factor as much as possible. That doesn't mean it will. which means you've got to try to. Okay. Sometimes you're going to get down to that quadratic and it won't factor any further. And then we've got to do something else when we go to solve these things. Okay, we're trying to just get factored form right now. Because once we can get if we can get factored form, the solving is the easiest part. Look at another one. Let's factor given a 0. Okay, not giving you a factor this time, giving you a 0. That's 2x cubed minus 3x squared. Sorry. So what's the difference given a 0 and given a factor? The number on the shelf is the 0. We don't have to take the opposite. You know, like on the previous problem, they gave us that x minus 1 was a factor, and we used positive 1 on the shelf. Here, they give us the 0 is positive 1, so we use positive 1 on the shelf. That's the only difference. Problem works exactly the same other than that. Now, we've got to think a little bit when we go to do our factors, but we'll get there. Drop the 2 down, multiply. -1, -1, -6, -6. And what do you know? There's a 0 there in the remainder. Should have been. They told us it would be. Okay. So, right now, the factors are 2x squared minus x minus 6. What's the factor that goes with k equals 1? X minus 1. Good. Now we got to factor that quadratic right there. We need to multiply -12, add to be -1. 2 times -6 is where the -12 comes from. 2 times -6 is -12. We needed to add to be -1. That'd be -4 and 3. Replace the -x with the -4x and a positive 3x. Group. First two have 2x in common. Second two have 3 in common. So the factored form for f of x, x minus 1, x minus 2, and 2x plus 3. Getting that factored form helps us. We'll go to do the next thing. Now, what that helps us do is finding the zeros. If we can get it in factored form, finding the zeros we're just going to take this polynomial and make that example E. We're going to find the zeros of that polynomial. Finding the zeros just means take the thing and set it equal to 0. And if it's in factored form, finding the zeros, you take each factor and set them equal to 0. So we said x minus 1 equal to 0, x minus 2 equal to 0, and 2x plus 3 equal to 0. So if we can get it in factored form, we end up with 3 very easy problems to solve, right? Because this first one, we should already know that the answer is 1. This one we add 2. X is 2. And this one's a little bit more work, but still not very difficult. X is negative 3 over 2. Now, those are the zeros of this polynomial. What does that mean? This is where the graphing calculator can come in handy. Okay, so what I'm going to do is I'm going to graph the original polynomial from example D. I'm going to graph this guy. That's the one I'm graphing. Okay. I'm going to get y equals on my graphing calculator. And I've got 2x to the third minus 3x squared minus 5x plus 6. And hit graph. I want to show you the relationship between those zeros we found with algebra and the graph. Okay. Zeros are the same thing as x-intercepts. Look at where this graph is crossing the x-axis. There's positive 1. There's positive 2. Those were zeros we found, right? We found the x equals 1 and 2. And then this one is negative 3 over 2. You can get y equals first. All right, then type 2x and hit this symbol. And that puts the x1, and then type your 3, and then you'll have to hit the right arrow to get out of it. There you go. Yeah. Yours doesn't have the newest operating system, so you're not going to have to hit the right arrow. You're going is that it doesn't do it. Yours is fine. You're just going to keep going.
Oh, okay. So it is 2/3.
Yeah, it is 2/3 power. Next thing you type is not in an exponent. All right, so see where this is crossing the x-axis. Negative 3 over 2, that's negative 1.5. It's crossing the x-axis there. It's crossing at x equals 1. That's 1. There's 2. What were the zeros of our polynomial we found when we worked them out? 1, 2, and negative 3 over 2. That's the relationship we're playing off of here. Is that where it crosses the x-axis are the zeros of the polynomial. They are the x-intercepts. Those are the same things. Zeros, x-intercepts, you might hear them called roots or solutions. They're all the same thing for a polynomial function. Zeros is what we tend to call them most in Math 100. Okay, so let's go a little further here, and let's take that same idea and find the zeros for a polynomial given one of the zeros. So far, they're giving us some of the information. We're building up to them giving us none of the information, okay? So here's next example, example F. Find the zeros of polynomial. Given. Here's our function, x cubed plus 4x squared minus 5, x equals 1 is a 0. Okay? So they're telling us one of the zeros. We should have 3 zeros at the end, including the one they gave us. Because the highest exponent in the problem is 3, that should match up. The highest exponent and the number of zeros you find should match up, okay? So what we're going to do is we're going to set up a synthetic division with 1 on the shelf, and we're going to run that through. And we get 0 there. And we've got x squared plus 5x plus 5 left. Now, we know that's factored form. This is what's happening. This should look familiar. It's one of the polynomials from before. Okay? Now, we did this one on, I think, example C. Maybe. Is that right? What did we know about that quadratic there? It doesn't factor. But we're not looking for factored form here. We're looking for zeros. We already know that 1 0 is x equals 1. We should be finding 2 more. Those other 2 should come from this guy, from the x squared minus 5x or plus 5x plus 5. How do we find them if that doesn't factor? Quadratic equation, quadratic formula. The x equals negative b plus or minus radical b squared minus 4ac divided by 2 times a. That's a quadratic formula. That's how we're finding those. Because it won't factor. It'll even work if it does factor. Okay? Once you get it down to x squared is the biggest part in there, you can use quadratic formula and it works every time. That's maybe your best bet here is to do that instead of, because sometimes factoring doesn't always work. Quadratic formula does. Okay? So it's kind of like, you can buy the potato peeler or a butcher knife. Potato peeler is only useful for peeling potatoes and a few other things, but a butcher knife, you can use that on pretty much anything, right? You could peel a potato with it if you wanted to. So I think this is a better tool. If I have to choose where I spend my money, I'm going to use the tool, get the tool that does the most work. This one does the most work. So we're going to work this out. It'll be 25 minus 20 over 2. That's negative 5 plus or minus the square root of 5 over 2. So my zeros are 1, negative 5 plus the square root of 5 over 2, and negative 5 minus the square root of 5 over 2. I'm going to get since those are real numbers, there's no I involved there, I'm going to get the decimal approximation for those so that when I look at my graph for this polynomial, we can kind of see where those are actually happening at. So let's get the decimal for those. Negative 5 plus the square root of 5. And then divide that by 2. 1.38, just 2 decimal places, about as close as you can get, as far as eyeballing it, negative 1.38. And then I'm going to do the minus one. So negative 5 minus the square root of 5 divided by 2. And that's negative 3.62. I'm getting those decimal approximations so that when I graph this, we know to look close to negative 3 and look close to negative 1. And it should be crossing the x-axis there. And also should be crossing at positive 1. So I'm going to graph that original polynomial. Clear this one out. X cubed plus 4x squared minus 5. Hidden graph. All right. There's positive 1. That's the easy one. Right? That's one we knew about. They told us about. That's a little bit past negative 1. I bet that's pretty close to negative 1.38 because it's not quite halfway to negative 2. So I know that's what that is. This one, that's negative 2. There's negative 3. Over here's negative 4. That's in between. Negative 3.6 something was between there. Okay, so that's that point. That's the zeros. The 1, negative 1.38, the negative 3.62. Those are the values that we're finding there. They're showing up on the graph. Now, it's nice when they cross at good numbers like 1. It's not as easy, you can't kind of guess at it when they cross in between because what are those numbers? And so you've got to do the synthetic division and then do the quadratic formula and stuff to get there. So that's going to be kind of key to what you're doing. Let's look at another one. Still doing the same thing, finding the zeros given one of them. So here's our polynomial. 4x to the third, 6x squared, minus 2x, minus 1. X equals 1/2 is a 0. So 1/2 goes on the shelf. It's a fraction, but it's just a number. Okay, it does work pretty nice here because I take that 4 and drop it down, and then multiply half of 4 is 2. So I don't really have to deal with fractions too much here. That's 8. Half of 8 is 4. Half of 2 is 1. I end up with 0. So that works out really nice. So now I've got 4x squared. Because I started with x cubed, I did synthetic division once. I now have 4x squared plus 8x plus 2. I can either factor that or use quadratic formula on it. It doesn't matter which one, but I know, what do I know about quadratic formula? It always works. So that's one of the reasons that you want to use it, okay? So if I'm going to use quadratic formula, is there any way that I could simplify it before I start? Yeah, everybody's divisible by 2. So I'm just going to divide everybody by 2 at the beginning because everybody's divisible by 2. So make the number smaller. So that becomes 2x squared plus 4x plus 1. And then do your quadratic formula on that. So x equals negative b plus or minus the square root b squared minus 4 times a times c divided by 2 times a. And a is 2 in this case. And then you're going to work that out. Negative 4 plus or minus. 4 squared is 16. 4 times 2 is 8. Times 1 is 8. So 16 minus 8 is 8. You got a 4 on the bottom. What's the square root of 8? Doesn't work out nice, so I got to simplify. 2 radical 2. What do we know about all 3 of these numbers on the outside? They're all divisible by 2, so divide them all by 2. Negative 2 plus or minus 1 radical 2 over 2. So my zeros, I got x equals 1/2. That's the one they gave me. And then I got x equals negative 2 plus the square root of 2 over 2. And x equals negative 2 minus the square root of 2 over 2. We'll get the decimal approximation for those so that I can see them on the graph. I know that that's what those are. Negative 2 plus the square root of 2 divided by 2. Negative 0.29. And negative 2 minus the square root of 2 divided by 2. Negative 1.71. So these are my zeros. So when I graph that original polynomial, I should see it crossing the x-axis at 1/2, negative 0.29, and negative 1.71. Okay, so I'm going to graph that original polynomial that we started with. 4x to the third plus 6x squared minus 2x minus 1. Graph. I'm going to check those. I'm going to hit trace and do 1/2. That's that spot right there. That's a 0. Okay. If I check the negative 0.29. That's that spot right there. Notice the y value is not quite 0, but it's real close, right? Remember, I rounded that number. And then negative 1.71. Ooh, yeah. The y value is almost 0. It's right there. You can see it blinking right there on the spot. So those are my zeros of the polynomial. The degree of the polynomial that I started with, or the highest exponent, was 3. I had 3 zeros. Okay. Now, here's how it kind of works. You're not going to be given that all the time. They're going to give you a polynomial and say, find the zeros. Good luck. And they don't give you any information. But here's the thing. They give you a polynomial. You got a graphing calculator, right? You can graph it and see where it's crossing the x-axis. So even if they don't give you one, maybe it crosses the x-axis at a good spot, and you can borrow one from there. That's what we're going to do, is we're going to use our graph to help us get started. Instead of having them give us information, we're going to use some information we can find using our graph. Okay? There's also some other information that we're going to find, and it's called the rational zeros theorem. Anything with the word theorem after it's always fun. So here's how it's worded. If P over Q is a rational number and a zero of a polynomial, we'll call that polynomial f of x because that's what we've been calling them all. Then P is a factor of the constant term, and Q is a factor of the leading coefficient. Okay. All right. Let's get an example. We're on H. Is that right? I think that's right. Okay. Now, here's what we have. P over Q. P is this number down here. That's P. I'm going to put that in a different color. This is P. This is Q. P is the constant term on the end. Q is the leading coefficient. It's got to be in descending order before we even start anyway. So P is always the constant on the end, the one that doesn't have a variable on it. Q is always the one in the front, and it's in descending order. Okay. Now, what we're going to do is we're going to make a list of the possible rational zeros. So we want the factors of P and then the factors of Q. Well, P is 2 in this case. What are the factors of 2? What things multiply to be 2? 1 and 2. But technically, it's plus or minus 1 and it's plus or minus 2. If you just stick 1 plus or minus out there on the front, that's fine with me. Okay? Then, what are the factors of 6? What are the things that multiply to be 6? 3 and 2. Don't forget about 1 and 6. Technically, it's plus or minus on each of those because you could have a positive 1 times a positive 6, or you could have a negative 1 times a negative 6. You have positive 2 times a negative 3. You know, it could mix and match to get that number, okay? So then you build your list. So we haven't built our list yet. This is the list of possible rational zeros. Okay? It's a set. What you do is you take the top factors, 1 and 2, whatever numbers are up here, and you divide by each one of the numbers that are in the list in the bottom. So if I divide 1 by 1, that's 1, right? 1 divided by 1 is 1. Technically, it's plus or minus 1. If I divide 2 by 1, that's 2, right? So it's plus or minus 2. I'm done with that guy. Then I go to 2. 1 divided by 2, 1/2. What's 2 divided by 2? 1. We've already got 1 listed. We don't need it again. Okay, so I don't have to put it down. Then I go to 3, the third one in the list in the bottom. 1 divided by 3 doesn't go evenly. So it's 1/3. 2 divided by 3 doesn't go evenly. 2/3. Then I go to the 6. What's 1 divided by 6? 1/6. I'm going to give myself a little bit more room here. What's 2 divided by 6? How much? 1/3. I've already got 1/3 listed. I don't need it again. These are the possible rational zeros for that polynomial. It doesn't mean that all of these are zeros. It just means that these are the only possible ones. Okay, we've narrowed it down from every number on the planet to a set of 12 numbers that it possibly could be. Okay, what that is going to help us do is when we graph this thing, if it doesn't cross at 1 or 2, and it crosses in between some x values, the in-betweens can only be these. So it's going to help us on our graph pick one to start with. Okay, so what we do is we graph our polynomial. So next step, after you get the possible rational zeros, and I'll go ahead and tell you guys, there is always at least one question on the final exam that asks you to just make that list. Doesn't ask you to do anything with it, but just make that list. There's always at least one, if not two, on the final. So you might want to put a star by that. Know how to do this. This is important. It's on the final exam. It's at least 2 out of 100 points, if not 4 out of 100 points that you can get on the final by just being able to make that list. Okay, so the next step after you get that list is to graph f of x. Okay, so we're going to graph that polynomial with a calculator. Y equals, clear that one out, 6x to the 4th plus 7x to the 3rd minus 12x squared minus 3x plus 2, and hit graph. All right, we see this thing crossing the x-axis in 1, 2, 3, 4 places. That shouldn't be a surprise. It had a 4th power as the highest exponent. Okay, now let's look for a good one that is in our list. Where's a good one? Look there, -2. If I hit trace and -2, I get 0 for y. That means -2 is one of my zeros. Okay, that means I can use it in synthetic division to break the polynomial down. Where's another good one? +1, right? So if I traced 1, its y value is 0. So that means, hey, that one will work in synthetic division as well. And I need it to work in synthetic division. I'd rather do synthetic division with numbers that are not fractions, right? Fractions are not fun, right? Doesn't make it easy. Regular numbers, plain numbers do, okay? Integers. So what I'm going to do is I'm going to take one of those values and use it in synthetic division. I'm going to use the -2 because that's the first one you guys gave me, and use it in synthetic division on that polynomial. Running that through. 6. What do you know? The remainder is 0. Okay, so our zeros, got x equals -2. Now here's the next thing that's happening. I also know that +1 worked because I saw it on my graph that it crossed the x-axis at +1, and I checked it by hitting trace and typing in a 1. That works. I can use it on the answer to this synthetic division to break that polynomial down. Because this one started at x to the 4th power. When I do synthetic one time, this is at x to the 3rd power. I don't have a whole lot of tools for solving x to the 3rd powers. I've got quadratic formula if I can get it down to x squared. So I want to do synthetic division on this answer using that 1 that we know it crosses the x-axis at. Okay. Drop the 6 down. 1, -1. Hey, there's the 0 as the remainder. Okay. So I found these two numbers using the graph. That's what you want to do. Okay. We made this big P over Q list so that we'd have some ideas about what numbers we could try. Okay. Back when I was in high school and we did this, we didn't have graphing calculators then. We had to guess and try one. If it didn't work, try a different one. That one didn't work, try another one. But making that list cut it down to 12 numbers instead of an infinite group of numbers that we couldn't, you just had to guess. So here, we didn't have graphing calculators. You guys got a tool that helps, all right? So now we've broken this polynomial down where we got two zeros. We got -2 and 1 are zeros. We've verified that with our synthetic division. Now we've got an x squared problem. And we can either factor that or use quadratic formula to get the other two zeros. Because if we solve that quadratic, we'll get 2 more. We should have 4 to end up with. Because the highest power on the original problem was 4. We got to have 4 answers. Okay? So, if we do quadratic formula here, because it always works. That's going to be -1 plus or minus 1 squared is 1. -4 times 6 is -24 times -1. So 1 plus 24 is 25 over 12. So that ends up being -1 plus 5 over 12. And then -1 minus 5 over 12. 2 nice numbers. -1 plus 5 over 12. That'd be 4 over 12. 1/3. -1 minus 5 over 12. Nice number. -6 over 12. -1/2. Those are my zeros. Was 1/3 in my list of P over Q? Yeah. Was -1/2 in my list? Yeah. Was that where they crossed on the x-axis? On the graph, if I type in -1/2, yes. If I type in 1/3, yes. So that graph can verify any real zeros that you find. And yes, I said real zeros because we're about to get to where we don't find all real zeros. Sometimes we have complex numbers that are zeros. It's nicer when they're all real because you see 4 places on the x-axis. That doesn't always happen. Okay. All right. Let's look at another one. Let's get a polynomial and just start from scratch and do all the work that it takes to find the zeros for a polynomial. So let's say we got f of x cubed plus 5x squared plus 2x minus 8. Okay. What's P on this problem? 8, Q, 1. What are the factors of 8? 1 and 8, 2 and 4. This one's an easier list because what are the factors of 1? 1. So our P over Q list, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. No fractions involved there. That's nice. Okay. How many zeros should we find? Why? Because the highest exponent is 3. Okay. What's my next step before I do synthetic here? What do I have to do to decide what goes on the shelf? And what I said, I had to guess at a number in that list back when I was in first learning this. You guys have a graphing calculator now. Graph the polynomial. Get one of its places where it crosses the x-axis. Borrow it from there. So we're going to graph that polynomial. X to the third plus 5x squared plus 2x minus 8. Now graph that and see where it's crossing. I can see 3 really nice places. So really all I'm going to have to do is verify that these are right. I know that the zeros should be at positive 1, negative 2, and negative 4. That should be my 3 zeros. When I get done, I'm just going to verify it with the synthetic division and quadratic formula or whatever method we try to use. But I'm just going to pick one to do synthetic with first. I usually pick the positive one if I got a choice. That way I don't have to deal with a negative sign. And there's always a chance of me messing up a sign if a negative is involved. So I'm going to do synthetic division with positive 1 because the graph crossed the x-axis at positive 1. Run that through. And there's the 0. Okay. We got a quadratic left because we started with x to the third. We did synthetic once. That breaks this down into x squared plus 6x plus 8. And I'm solving that. I can do quadratic formula or I could factor. Quadratic formula works every time. Factoring doesn't always work. It would work with this one. We'll go ahead and do it with quadratic formula. That'd be negative 6 plus or minus the square root. 6 squared is 36. 4 times 1 is 4 times 8 is 32. 36 minus 32 is 4. So we end up with 6, negative 6 plus or minus 2 over 2. So negative 6 plus 2 negative 4 over 2 is negative 2. We knew that would happen. And then negative 6 minus 2 is negative 8 over 2, which is negative 4. We knew that would happen too. Okay, so our zeros are x equals 1, x equals negative 2, and x equals negative 4. throw in this one. What letter are we on here? J. Here's our polynomial. F of x, x to the fourth power, minus 7x to the third power, so 18x squared, minus 22x, plus 12. P over Q plus or minus 12 over 1. So we need the factors of 12, which is 1, 2, 3, 4, 6, and 12. Factors of 1. So the list is just the factors of 12. Anytime that leading coefficient is 1, it sure makes things a lot easier in a lot of ways. And so there's my possible rational zeros. -7, 18, -22, and 12. What's the next thing I need to do? Graph it. Good job. Y equals x to the fourth minus 7x to the third plus 18x squared minus 22x plus 12. How many times does it cross the x-axis? Twice. That's not like what we've been having. We've been having it cross the exact same number of times as the highest exponent. This one only crossed 2 times, but the exponent was 4. So that must mean something different is happening. But those 2 places where it crossed are zeros. What are those 2 numbers? Or +3 and +2, right? Pick one to use first. I'm going to start with 2 because it's smaller. And I'm going to use it to do synthetic division with that. Because I know 2 is a 0, this thing, because it crossed the x-axis at 2. But run that through. Oh, not 9. That's about -5. -10, 8, 16, 6. There's that remainder of 0, like I knew would happen. But I took it from x to the fourth power to this stuff is x to the third power. That's not far enough down for me to do quadratic formula yet. So I need to do another synthetic division on that part using what number? 3, the other place it crossed the x-axis at. The 1 down, run the 3 through there. There's that remainder of 0 again. So far, my zeros are x equals 2 and x equals 3. There should be 2 more. They're coming from x squared minus 2x plus 2 equals 0. Do quadratic formula. X equals -b plus or minus the square root of b squared 4ac divided by 2a. That's going to be 2 plus or minus. 2 squared is 4 minus 8 is -4. What's the square root of -4? 2i. That's what's happening different on this one. Now, what do we know about all 3 of those numbers? All divisible by 2, so divide them by 2. Be 1 plus or minus I. So my zeros are x equals 1 plus I, x equals 1 minus I. Notice those are complex. Complex zeros don't show up on the graph. They don't cross the x-axis because that 1 plus I is not an x. It's not a number on the x-axis, so it can't show up. Your graph won't cross on that place. So if you know you've got an x to the 4th power problem and it doesn't cross in 4 places, then you know, oh, I must have some complex solutions out of that. Either that or I've got some repeated zeros. And we'll see that in another example here. Repeated zeros and complexes show up differently on the graphs. Okay. All right. So let's look at one second. All right, let's look at this one. F of x equals x cubed minus x squared plus x minus 3. What letter wrong? Okay. All right. P over Q shouldn't be too bad on this one. Small numbers of 3 and 1. So what are the factors of 3? 1 and 3. So that's the only factors. Only things that could be the real rational zeros for this one. That works out real nice because I ain't got a whole lot to choose from. But I still go through the process the same way. Once I get my P over Q list, what's the next thing I do? Graph it. Graphing x to the 3rd minus x, x to the 3rd minus x squared plus x plus 3. Is it plus 3 or minus 3 that I wrote? I wrote minus 3. Sorry. And I typed in a plus 3. That'll make a difference. All right. I didn't do what I wanted to do. Let's make multiply. Hang on. I have to change this polynomial. I didn't do something right. Yeah, I did. The mismultiplied. That should be, let's change that polynomial. Won't change what we've done so far. Let's make that a minus 5x right there so that it does something different. P over Q list is exactly the same. So I'll go back up here to my y equals. And I'll just start over x to the 3rd minus x squared minus 5x minus 3. There we go. That's what I wanted to do. All right. Okay. Now, where's it touching the x-axis at? Yeah, it's crossing at 3. And what's it doing here at positive 1? It's just touching, not going through the x-axis. coming up to it and bouncing off of it. What that's a clue of is that the negative 1 is a repeated 0. Means it works more than once. Okay? This, anytime it goes through the x-axis, you know it works one time or an odd number of times. Here we've got a power of 3. The exponent is 3, is the highest one we have. So we should have 3 zeros. It's touching the x-axis in 2 places. It's crossing here, so that counts once. It's touching here, so that should count twice. That's what I want to show you here. Is that any time the graph is doing that, either coming up from the bottom and bouncing off the x-axis is the way I describe it, or it could be coming down from the top and hitting the x-axis and just touching it, and then going back up. What that is called is a repeated 0. Okay, you just need to be able to recognize that that's a repeated 0. Okay, all right. Now, process for solving this thing's exactly the same though. So what we would do is I'm going to start with 3 on the shelf because it crossed the x-axis at 3. That's a good place. It's positive. It's easy to run through. And that leaves us x squared plus 2x plus 1, which is quadratic, and I can use quadratic formula. And then work that out. So that's going to be negative 2 plus or minus the square root of 0. It's the square root of 0. 0. What's negative 2 plus 0? Negative 2. So we got x equals 3. And then we got negative 2 over 2. What's negative 2 divided by 2? It's negative 1. In parentheses, beside that negative 1, you write multiplicity of 2. What that means is it counts twice. Because how many zeros should I have total for that problem? 3. The 3 counts as the first one, but negative 1 counts twice because the graph bounced off the x-axis at that spot. Anytime it bounces like that, it's going to count an even number of times. Okay? And since when we did quadratic, that was the only answer we got, that negative 1 counts twice because it comes from a quadratic formula. Okay. All right. Let's work on building some polynomials. So solving really doesn't get any more complicated than any of the problems that I've shown you. Okay. Building polynomials is the last bit of the Math 100 course that we got to go over here. So building polynomials is a whole lot of multiplying, and so a lot of distributive property happening. So building so let's start with a polynomial. They're going to have to give us a ton of information here. They've got to give us the zeros of the polynomial for us to build it. Okay, so the zeros are negative 1, 2, and 4. I don't know what letter it is. L. L. If the zeros are negative 1, 2, and 4, that's what they've given me. So I can build a factored form from those zeros. What's the factor that goes with negative 1? X plus 1. What's the factor that goes with positive 2? Positive 2. What's the factor that goes with 4? Here's that factored form coming back up that we started the night with. Okay, we're working backwards though. We've got the factored form to start with. Let's find the original polynomial. So we've got to multiply this thing out. It doesn't matter which two you start with. I'm going to start with these two over here and multiply them together. So it's x times x is x squared. X times negative 4 is negative 4x. And then distribute negative 2x to the x and negative 2 to the negative 4. And still got the x plus 1 hanging out. Hadn't done anything with him yet. And then that becomes x squared minus 6x plus 8. And then I'm going to distribute x to that thing. So it'd be x to the third minus 6x squared plus 8x. And then I'm going to distribute 1 to it. So that'd be x squared minus 6x plus 8. And I'm just stacking that up back the way I did back in R when we were doing section R3 and multiplying polynomials way back about a month ago. So there's x cubed, be negative 5x squared, positive 2x plus 8. And there's my polynomial that does those things. Now, I can check that because if I know the zeros were negative 1, 2, and 4, then where should it cross the x-axis? At negative 1, 2, and 4. So if I just take that polynomial that I built and graph it, x to the third minus 5x squared plus 2x plus 8. And make sure it crosses at those places. There's negative 1, there's 2, and there's 4. Then I did it right. It's very unlikely that if you mismultiplied or misadded somewhere that your final answer would do the right things. It is very, very unlikely that if you mismultiplied or misadded that your polynomial would do the right thing at the end. Okay? So what if they tell us a little something different about that polynomial? Let's say they said that the zeros were 3 and negative 2 with the multiplicity of 2. So they usually abbreviate multiplicity with MULT. Okay. The only thing that changes about how you do things is how you set it up. You got the x minus 3. That's the factor for positive 3. What's the factor for negative 2? X plus 2. The multiplicity is 2. So that means that one happens how many times? Twice. You just put another x plus 2 up there. That multiplicity of 2 makes that happen. That's all that does. The work's still the same. It's still just multiply a couple of them together and then go from there. So I'm going to multiply. I'm a right to left kind of person on this stuff. I usually work with those two and then multiply the one that's in the front last. So that's going to give me x squared plus 2x plus 2x plus 4. We got the x minus 3. It's x squared plus 4x plus 4. Distribute again. X cubed, 4x squared, 4x, and then I'm distributing negative 3. That's negative 3x squared, negative 12x, and negative 12. And then total that up. not too bad. What if they do something a little different? Trying to give you all these scenarios that are going to come up. Okay. Say they give us our zeros, and they say the zeros are 1, -5, and positive 5. Let's do that. And it goes through f of 2 equals 10. There's an additional piece of information there that f of 2 is equal to 10. So that's more specific on the polynomial. Okay. Here's how you start it. What this is going to do, this part right here, the f of 2, all that's going to do is going to add a to the problem. So that means you're going to have a leading coefficient other than 1 at the end. Okay. Here's how you work it, though. Starting out with a polynomial, get your factors just like before. So x minus 1, x plus 5, x minus 5. The a is added because they gave us this other bit of information. Okay. Now, f of 2 is equal to 10. So the 2 is actually what in this problem? It's the x. So I can find out what a is before I even start. It's actually easier to find out what a is right now than it would be to do it at the end. So if I know x is 2, I can do this. And then I know when I plug a 2 in, I'm supposed to get 10. So 2 minus 1 is 1. 2 plus 5 is 7. 2 minus 5 is -3. 1 times 7 is 7 times -3 is -21a is equal to 10. How do I get a by itself? Divide by -21. (10 over -21) or -10 over 21. That's what a is. We're going to use that at the end. Okay? We found it at the beginning so that we could use it at the end. We're going to go back, and now I've got this piece kind of already set up. The only difference is I know a is actually -10 over 21. And then I'm going to multiply everything out. I'm going to multiply these two guys together first. X plus 5 times x minus 5. That one actually is a difference of squares factoring. So x times x is x squared. Positive 5x and negative 5x cancel out, and you get minus 25 in there. That shortens this one up a little bit. And then I'm going to multiply this x minus 1 to that thing. So x times x squared is x cubed. X times -25 is -25x minus x squared plus 25. Still not done. Gotta rearrange. X cubed minus x squared minus 25x plus 25. And then all I have to do now, since I've got that a, is distribute it across the whole thing. -10 over 21 x cubed plus 10 over 21 x squared plus 250 over 21 x minus 250 over 21. So our final polynomial doesn't look real pretty, but The only extra added step there at the end was distributing a number to everything. All right. Now, let's get into what if the zeros are not nice integer numbers. Maybe they're square roots or complex. Do a couple of those, and then we'll be done. Okay? Two more examples, and we're out of here, guys. It's been a long semester. All right, so I don't know what letter we're in. It's not N, is it? It's N in it. It's an O. Donut example. Patriotic sprinkles donut. Okay. All right. So we got, here we're given the zeros. 3 square root of 5. Here's the kicker on this part. There's this thing called the complex conjugate zeros theorem. We won't go through the spiel of writing it out. It doesn't help you to write it out. All it tells you is that anytime you have a radical or a complex number as a zero, and they tell you about one of them, there's another one hidden. That square root of 5 also has negative square root of 5 as a zero. This one, they kept a secret. Okay? Think about it like this. Where did the square root of 5 come from? It came from taking a square root to solve the problem. Where do we use square roots to solve problems? In the quadratic formula. What did the quadratic formula have in front of the square root? Plus or minus. So if square root of 5 came up to be an answer, negative square root, it should have been plus or minus the square root of 5. So we have to put the negative in there as a zero. Okay, they're not always going to tell us about that one. Okay, so we've got to put that one in there ourselves, and then we set it up. X minus 3, x minus the square root of 5, x plus the square root of 5. Always multiply your stuff with the square roots together with each other. Okay? The reason you want to do that is because the square roots will go away when you do this. When you multiply these square root ones together, the answer should not have any square roots in it. Okay? So when I multiply x times x, that's x squared still. X times square root of 5 is x square root of 5. And then negative square root of 5 times x is negative x square root of 5. Negative square root of 5 times positive square root of 5 is negative square root of 25. We still got the x minus 3 in the front. We haven't done anything with it yet. But when we simplify this part, the square roots of 5 cancel out. What's the square root of 25? 5. So this is really x squared minus 5. So it works out pretty nice. It shortens it up pretty quickly. And then we distribute again. X times x squared, x cubed, x times negative 5, negative 5x, minus 3x squared, plus 15. Last thing is just put it in the right order. X cubed minus 3x squared minus 5x plus 15. So anytime there is a square root as a zero, you need to put the other side of it. If they give you the negative one, you need to put the positive one. Okay? If they give you 1 plus the square root of 3, what's the other one? 1 minus the square root of 3. That's still the case. The factors that go with that, like you say you had one that's 7, and those two factors, the factors are x minus 7, x minus 1 plus the square root of 3, x minus 1 minus the square root of 3. And then when you distribute, everything works the same way. Okay? So that we're not going to completely do that example there. But you could, heck, let's just go ahead and do it. I'm sorry, I lied. 3 examples. There we go. Let's go ahead and do this because I think it's going to help you because they're going to do that to you. They're going to give you a 1 plus square root of 3. So I'm going to multiply the stuff with the square roots together first. X times x is x squared. X times -1, negative x. X times negative square root of 3 is negative x square root of 3. And then I run the -1 through there. So that's negative x again. That's positive 1. That's positive square root of 3. Then I'm running square root of 3 through there. So that's positive x square root of 3. That's negative square root of 3. And that's negative square root of 9. All of that stuff there is just multiplying these two together. Still got x minus 7 to deal with. When I simplify, negative x radical 3, positive x radical 3. What happens to those? They cancel out. Positive square root of 3, negative square root of 3. They cancel out. What's the square root of 9? It's really 3. So this is really a minus 3 right there. So it's no more square roots in there. When you multiply that out, all the square roots should go away. So I've got x squared. I got a negative x, it's a negative 2x. I got a positive 1 and a negative 3. So that's negative 2. All of that ugly stuff simplified down to that nice little trinomial. And then I just distribute again. X times x squared is x cubed minus 2x squared minus 2x. 7, negative 7x squared, positive 14x, positive 14. There's my function. X cubed minus 9x squared plus 12x plus 14. All right. Let's get one with a complex 0. We'll be done for the night or the semester, whichever way you want to look at it. Here's your zeros. 3 and 2 plus I. What else do we know is there? 2 minus I. That one, we'll call it hidden. Or they kept it a secret. They didn't tell us about it. It's the conjugate of 2 plus I. You're always going to have that. If it's radicals or complex, you're always going to have to change the sign in the middle. Plus I, you got to have the one with the minus I. If they give you the one with the minus I, you got to add the one with the plus I. Okay. Then set up your factors. X minus 3, x minus 2 plus I, x minus 2 minus I. And you always want to multiply the stuff with the i's together first. Just like with the square roots. It works the same way. The only difference is instead of having like a square root of 9 there, we're going to have something with an I squared there. And what do we know I squared turns into? -1. So that's the only difference that happens here. The I stuff should cancel out, and any I squared turns to -1. So x times x is x squared. X times -2, -2x. X times negative ix. Then distribute a -2. -2x again. Positive 4. Positive 2i. Then distribute a positive I. Positive ix. -2i. Negative I squared. Still got the x minus 3. And then I'm going through all that. and trying to simplify everything. So I got a positive or negative ix, and I got a positive ix there. They cancel each other out. I got a positive 2I. I got a negative 2I. They cancel each other out. I squared, that's actually negative 1. So that's minus negative 1. Okay. So I end up with x squared minus 4x plus 5. Because minus negative 1 turns into plus 1. So 4 plus 1 is 5. And then I'm distributing again. X times x squared is x cubed minus 4x squared plus 5x. Then the negative 3x squared, positive 12x, negative 15. Final answer. X cubed plus 7x squared plus 17x plus 15. All right. A lot of information here. A lot of stuff to look at. If you see some stuff about end behavior, don't forget you can graph polynomials on your calculator and see what the ends are doing. Okay? So end behavior, kind of a shortcut to that somewhat is if it's got an odd degree, it's either going to go up to the left and down to the right or the other way. And that leading coefficient, that A that we were finding earlier, if A is negative, it does this. If A is positive, it does this. If it's got an odd degree, like the highest exponent's a 3, a 5, a 7, something like that. If it's an even degree, so they're both going to go up if A is positive, or they're both going to go down if A is negative. Even degree follows the same rule as quadratics did when we did which way does it open. The leading coefficient, if it's positive, it opens up. If it's negative, it opens down. The even degree follows the same as a quadratic does, because quadratics have even degree because they're x squared. Even degree means highest exponent's a 2, a 4, a 6, 8, 24, anything. But that the end behavior, that's one of those easy questions. You can graph it. Sometimes the graphs are really large. You got to zoom out a lot. But if you can look at, use that little key there, it can help you on the end behavior stuff. Okay. So you guys get to make the decision for everybody. Are we testing on Monday coming up or